Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. As he said, my name is Amy Sink and I am one of the math specialists here at the Learning Liaisons. And I'm so excited to spend my Wednesday night with you, just working through a couple of problems, a few problems, more than a couple, to help clear up that testing confusion for you. So, like he said, these problems span from kindergarten all the way through 12th grade. So we are going to go over a lot of different problems today. But before we get started, I always like to get to know who's in the room. So let me know in the comments where you're from, what test you're prepping for, and do you have any big plans for this Labor Day weekend? Where are you from? What test are you prepping for? And what plans do you have for this Labor Day weekend? My husband and I will just be kind of laying low, no big plans. Maybe take the baby to the beach. Who knows? But that's about it. So where are you from? What test are you prepping for? And what big plans do you have for Labor Day? Now, as I am working through these math problems, if you have any questions, please let me know in the comment box. I'm more than happy to answer any questions that you might have. That's why we're here, to answer questions and clear up any confusion you might have. Also, if there's a specific kind of problem that you've been dying to see me solve, or you got stuck on this week as you were prepping for your exam, please let me know that in the comments as well. I'm more than happy to include those problems in the upcoming weeks. In fact, it makes it better for you and me because I get to work through problems that you want to see, and you get to see problems worked out that you want to see. So it's a win-win for everybody. Hey, Joseph. Hey, Amani. Oh, it's your birthday on Friday. Happy birthday to you. The Praxis 5161 and the Pro Ed. I will be going over math problems tonight. You're more than welcome to stay, Amani, if you have an upcoming math exam as well. But I did just want to let you know we are not going to be over any professional ed problems tonight. We will just be going over math problems tonight. Hi, Inde. Math 6 through 12. Awesome. From Florida. A couple people from Florida tonight. I love it. I'm from Central Florida, about an hour north of Disney World. And that's enough about me. Let's go ahead and get started with our first problem. So, what is the axis of symmetry for a parabola whose equation is y equals 3x squared minus 12x plus 10.53? So this is a problem that you're going to see on a 6 through 12, 7 through 12 exam. And axis of symmetry is just the line, the imaginary line that goes through that parabola that cuts that shape in half in a way that when we fold it on top of that axis of symmetry, it's the same on both sides. So even though this is a 6 through 12, 7 through 12 problem, my pre-K through 6 people need to understand what symmetry is. So symmetry means that I can draw a vertical or a horizontal line through, or a diagonal line really, through an object or a shape, and it's going to create equal things on both sides. So when we're talking about a parabola, and for my high school people who have to know how to graph parabolas, this is going to be an upward facing parabola. So when we're talking about a parabola, let's just draw a random parabola. This is not this parabola. It's just a random parabola. And I draw my axis of symmetry. It's going to go like this. And we notice that this side of the graph is the same as this side of the graph. That's what axis of symmetry means. Now, how do I find that axis of symmetry? I'm looking for the point of my vertex. Yes, exactly, Inde. I'm just giving a little bit of background knowledge for people who don't know that. So if this is my vertex, vertex being the bottom or the minimum or the maximum point of this parabola, the axis of symmetry is going to go straight through that vertex. So how do I find the vertex? Well, if it's in vertex form, it's super easy. F of x equals x minus h squared plus k. hk is your vertex. So if my quadratic equation is written in this form, then I'm golden because my axis of symmetry would just be the x value of that. However, we've got a standard form parabola here. So what I need to do is find that x value. How do you find the x value of the vertex of a parabola? You do negative b divided by 2a, where this is going to be a, this is going to be b, and this is going to be c. So I can take those values, plug them in, and that is my axis of symmetry. So I have negative b over 2a. Now, why did I write negative 12? Because the formula says to do a negative b, but b is a negative 12. And so in order to make sure I don't make a silly negative positive mistake, I'm going to write negative, and then I'm going to actually write the value of b there. Negative times a negative is a positive, so that equals positive 12 divided by 2 times 3 is 6. 12 divided by 6 equals 2. So the axis of symmetry is the line x equals 2. So it's actually going to be over here somewhere where then my parabola is going to go up like that. Now, what if I needed to find my entire vertex? What if I needed to find my entire vertex? Well, I know that my x value is 2. And then if I just need to find my y value, I can take that 2 and plug it in for my x values here. So I could do y equals 3 times 2 squared minus 12 times 2 plus 10.53, and that would give me my y value of my vertex. They didn't ask us for that, so I'm not going to solve that, but I just wanted to give you some perspective on what you would do if you needed that information. So in this case, our answer is C. Let's move on to problem number 2. A triangle, sorry, I need to get my water. A triangle has coordinates. P is negative 2, 3. Q is 9, 7. And R is negative 3, negative 5. What is the difference between the slope? Oh, Lordy, here I am including the answers here. We're just going to erase that. And we're just going to erase that because I don't want you to see. I mean, you already saw it. Let's be honest. So what is the difference between the slope of lines PR and QR? All right. So to solve this, I can do a lot of different things. If I know what slope means and I know what slope is, I'm going to jump right to that slope formula and find the slope of PR and then find the slope of QR. And then what am I going to do? Subtract them because they're asking you for the difference between those two lines. So if I didn't know that, I could attempt to graph it. So I'm actually going to start there for my elementary people because you have to understand how to graph a point. So this is why I do problems like this for those of you who are new, because it's important for me to try to give problems that are appropriate for everybody. This problem's not appropriate for everybody. However, there are pieces and parts that are appropriate for everybody. So if I were to graph this, I would have my coordinate graph here. And P is -2, 3. So this is my X value, my Y value, my X value, my Y value, my X value, my Y value. And so when I graph this, I need to go -2 on the X axis. The X axis is my horizontal axis and the Y axis is my vertical axis. How do I remember which one comes first? X comes first in the alphabet. So X is going to come first in my coordinate, in my ordered pair. I know that positive goes to the right and negative goes to the left and positive goes up and negative goes down. So all that said, if I'm graphing -2, 3, I'm going to go left -2, 1, 2, and down 3. And that's going to be my point P. So I'm going to go ahead and do that. -2 down 3 gives me P. And then Q is 9, 7. So over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 7. 1, 2, 3, 4, 5, 6, 7. That's going to be up here, and that's Q. And R is -3, -5. So -3, -1, 2, 3, 4, 5. Now, that looks like it could be a straight line. It's not, but it looks like it could be. But it actually is going to create a triangle. You notice that graphing that really, really didn't help. However, it's important for me to show you that because sometimes when we choose a method to solve a problem, it's not going to be successful every time, and that's okay. So graphing that was not helpful. It was helpful for my K to 6 people to be able to see that, but it wasn't helpful for us in solving this problem. So now I need to just go to my slope formula. My slope formula is y minus y over x minus x, which is also known as rise over run. Now, a lot of times you will see, oh my goodness, Joseph, thank you so much for catching my error. It is not -2, -3. It's -2, +3. See, everybody makes mistakes. Everybody makes mistakes. So instead of -2 down 3, Joseph is absolutely right. We're going -2 up 3, which definitely creates more of a triangle. I'm so glad you said that because I did graph this earlier and I was like, I don't remember my triangle being that skinny, but I guess it is. So thank you for pointing that out. moving forward with our conversation about slope, a lot of times you'll see the slope formula as y2 minus y1 over x2 minus x1. However, those 2's and those 1's really are not necessary, because a lot of times people will get confused with, well, is my R or is my P the 2 or the 1? It doesn't matter. As long as you're consistent in keeping the same point in the same spot, you're good. So if I'm going to find the slope of PR, I'm going to do y minus y, 3 minus negative 5, over, now because I did the 3 first, I need to do the negative 2 first. X minus a negative x. So I have 3 plus 5, which is 8. And I have negative 2 plus 3, because a negative times a negative is a positive. So this becomes one big plus sign. 8 equals 8 divided by 1, which is 8. So the slope of PR equals 8. That makes sense when I look at my graph, because 8 is a very steep slope, and this is a very steep line. Now, I'm going to go ahead and find the slope of QR. So QR, my points are 9, 7, and negative 3, negative 5. So I'm going to do y minus y, 7 minus negative 5. And because I did the 7 first, I'm going to do the 9 first this time. 9 minus negative 3. 7 minus minus 5 is going to create that plus sign. And minus minus 3 is going to create a plus sign as well. 7 plus 5 is 12. 9 plus 3 is 12, which equals a slope of 1. Now that I've found both slopes, I'm going to go ahead and find the difference. So all I'm going to do is do 8 minus 1, which equals 7. So A is our answer. Yep, I used the slope formula for PR. You're absolutely right. All right, let's keep going. Thanks again, Joseph, for catching that error of mine. That's what we're here for, right? When these numbers are ordered on a number line, which one is the closest to the number negative 1? This is a perfect K6 problem. This is a perfect GK problem. This is a perfect middle school problem, honestly. So this problem really encompasses a lot of those assessments that are K through 8. Why? Because it's percents, decimals, fractions, and negative numbers. So which of these numbers is closest to the number negative 1? I can automatically cross off 2 of the answers. And when I'm taking an exam like this, I am going to look for answers I can quickly get rid of. Which answer choices can I quickly get rid of? I can quickly get rid of 102%, and I can quickly get rid of 9/10. Why? Because those are both positive numbers. And we're looking for the number that's closest to the number negative 1. So if I have 0 right here, and I have positive 1 right here, and I have negative 1 right here, and I have 102% and 9/10, 9/10 is going to fall somewhere right here-ish, and 102% is going to fall somewhere right here-ish because it's larger than a value of 1. Those aren't anywhere close to a negative number. So those are not going to fall anywhere near negative 1, which means, my head is covering. There you go. So I can cross off A and D automatically, and now I'm left with 2 answer choices, and that's it. So if I was taking this on my exam and I was running out of time, this is a great time for me to guess because I'm down to a 50-50 shot. However, we're not going to guess today. So how do I figure which one of these is closer to the negative 1? Well, the first thing I'm going to do is take a look at what these numbers truly mean. So let's make this number line a little larger. So I have 0, I have 1, and I have, I'm actually going to move that 0. 0, 1, -1, and then let's keep extending that, and let's call that -2. All right, so we already know that 102% is going to fall like right there, and 9/10 is going to fall like right here. But how do I know where -0.875 is going to fall and -1 and 21/24 is going to fall? Well, if we think about a number line to the right, we go 0 and then we continue until we hit the number 1. So I have 1/4, 1/2, 3/4, 1. When I go to the left, it's going to be the same thing. So I have 1/4, 1/2, 3/4, -1, -1 and 1/4, -1 and 1/2, -1 and 3/4, and -2. So if I conceptually think about where these numbers are going to fall, if -1/2 is here, -0.875 is going to be somewhere around here, right? -0.875, because that 8 has a greater value than 0.5, so it's going to fall closer to that -1. But then this, if I think about what I know about fractions, 21/24 is really, really, really close to that next whole number, because I've got well over half of that fraction. 1/24 is really small. I only have a tiny little bit of my whole, because remember, a fraction is just a part of a whole. And so if you can get yourself to conceptually understand numbers like this problem is going to be a super quick problem for you. And so 21/24 is going to be really close to that next whole number, which means if I have -1 already and I'm really close to that next whole number, I'm going to be like right here for -1 and 21/24. Which one is going to be closer to -1? -8.75. Now, if these two were much closer to each other and I needed to use not number sense, but actual operations to figure this out, I would divide my fraction to figure out what decimal it was. So you can take any fraction and convert it into a decimal by doing basic division. So I would do 21 divided by 24. Now, some of you are thinking, why did you put the bigger number on the outside? Because when I have a fraction or a division, the top number goes on the inside. And so because this is a fraction that's less than 1, I'm going to have an answer that's less than 1. So 24 can go into 210, 8 times. 8 times 24 is 192. When I subtract those, I get 18. Add a 0, pull it down. And when I divide or figure out how many times 24 can go into 180, it's 7 times. Are you noticing what's happening? 7 times 24 equals 168. Subtract, I get 12, add a 0. 24 can go into 120 5 times. Interesting. So this is actually -1.875, which puts it much closer to that -2 value. Anyways, B is the answer. After all that was a lot of rabbit trails, but it was appropriate for all of us to really understand that number sense of decimals, fractions, and percents. Let's do a little geometry problem. Charity is putting a pool and a half-circle garden in her backyard. The design can be seen below. How much larger is the square footage of her pool than her garden? Round to the nearest foot if necessary. So let's process what this problem is asking us to do before we get started. So this problem is asking us to find how much larger is the square footage of her pool than her garden. How much larger, oops, that was a crooked line. How much larger means I'm going to be doing a subtraction problem because I'm trying to figure out that gap between the two. So I'm trying to figure out how much larger is the pool than the garden. Am I finding the perimeter of the pool? Am I finding the area of the pool? Am I finding how much tile I can put on the pool? I'm looking at the square footage of the pool. Square footage automatically tells me I'm looking at area because area gives us units squared. So I need to find the area of my pool and the area of my garden. So I'm going to write area of the pool. I need to find the area of my garden, and then I need to subtract. Well, area of the pool is going to be pretty straightforward. How do I find the area of a rectangle? Area of a rectangle equals length times width. So I can literally just do 8 times 18. Why? Because 8 is the length and 18 is the width. So 8 times 18 is 144. So the area of the pool is 144. Now I need to find the area of my garden. How am I going to do that though? I notice that my garden is a half circle. Why is that important? Because technically, if I were to draw a circle, could I cut that circle here? I could. So I really don't know if this circle is a half circle or not unless they tell me that the length of the pool is the diameter of the garden, or that the garden is a half circle. All of that vocabulary tells me that this garden is a half circle, and that's critical. So now that I know that's a half circle, I can find the area of the circle, which is pi times r squared, r being the radius. So I need to figure out what the radius is. Well, the radius is just half the diameter. In a circle, if I have a center point, the diameter goes through the center, and the radius goes from the center to the outside of the circle. So those are all different radiuses. So that said, if I know that this measurement is 8, then I know that the radius is 4. That doesn't make sense. I just realized I created this problem last night, and if that's 8 and that's 4, then this measurement can't be 25. I need to fix that because the radius has to be 4, which means that whole length needs to be 18, 19, 20, 21, 20, 22. So that needs to be a 22, and I need to fix that in my master. Okay, moving on, which means none of these answer choices are going to be right because I did it based off of a radius of 7, because 25 minus 18 is 7. So we're just going to do a little bit of this and keep going. So all that said, my radius of this circle is 4. So what does that mean? That means that that means that the area of my circle equals pi times 4 squared, which is 16 times pi. And because they said to round to the nearest foot, we can assume that pi is going to be 3.14. So 3.14 times 16 equals 50.24. But that is not the measurement I'm going to use. Why? Because that's the area of the whole circle. My garden is only a half circle. So I'm going to divide that measurement by 2 to get a measurement of 25.12. Because we're rounding to the nearest foot, I'm going to call that 25. So now I know the area of my garden is 25. So I'm going to do 144 minus 25, and I get the difference is 119. Now, I see a couple questions. Why P minus G? Because I just called the pool P and the garden G, and then went from there because I was trying to come up with a plan to solve my problem before I solved it. So I knew that I was finding the difference because it said how much larger is the square footage of the pool than the garden. So I just knew that I was going to do pool minus garden. And how about the 25 feet? That was a mistake. It should have said 22 feet. That's all. All right, moving on to problem number 5. On a 2,520-mile road trip with 2 of her friends, Sam determines her car consumes 16 gallons of gasoline for every 280 miles traveled. If the average cost of gasoline is $4.30 per gallon, how much in dollars will each person pay if they are splitting the gas bill evenly? So we've got quite a problem here. We've got a road trip. We've got gallons of gas. We've got for every amount of miles traveled. We've got the cost per gallon. And then we're trying to figure out how much every person is going to pay if they are splitting that gas bill evenly. So I've got quite a plan that I need to come up with here. So if we're trying to figure out how much each person is going to pay, we need to figure out what first. What do we need to figure out? We need to figure out how much gas they are going to buy, and then we need to figure out how much total money it's going to cost. So if I was working backwards, I would need the total cost, and then I need to divide that cost, right? But in order to find that total cost, I need to know how many gallons of gas they're going to use. So how am I going to figure out how many gallons of gas we're using? Well, that's an interesting question. So we know that we are on a road trip that is 2,520 miles, right? And her car is consuming 16 gallons of gas for every 280 miles traveled. So if I create a road, here's my road. And that road is 2,520 miles. Reconnect. Once I've gone 280 miles, I know that I need to buy 16 gallons of gas, right? Because for every 280 miles, it's 16 gallons. So here's 280 miles, and I've used 16 gallons. And then here I went another 280 miles, so I bought another 16 gallons. And then I went another 280 miles, so I bought another 16 gallons. So what I need to do is I need to divide my 2,520 by 280. That's going to tell me how many times I had to fill up and buy 16 gallons of gas. Thank you, Joseph, for answering that question. I appreciate it. So if I do 2,520 divided by 280, that's going to tell me how many chunks of 16 gallons I have to buy, or how many times I need to fill it up. Exactly. You are absolutely right. So 2,520 divided by 280, that gives me 9. What does the 9 represent? The 9 is the number of times I'm going to have to go buy 16 gallons of gas. So if I multiply the 9 times 16, I can figure out how many gallons I'm buying. So 9 times 16 equals 144. I seem to like that number in math today. We used that number earlier. What does 144 represent in this problem? Because if you have a multi-step problem, you are going to get stuck if you can't consider what each of these numbers represents. You're going to get lost in the weeds of your work. So what does the 144 represent? The 144 is the number of gallons of gas I've purchased. Excuse me, I'm sorry. So now if I know how many gallons it's going to take me to drive 2,520 miles on that road trip, what do I need to do next? Now I need to multiply that times $4.30. If I take that 144 gallons and multiply it times $4.30, that's going to give me the number, or the cost, the total cost of this trip. So 144 times $4.30. I'm just going to go ahead and do that in my calculator so that we can save a little bit of time. But some of you, GK people, K6 people, you might see a problem like this and you won't have a calculator. And doing that long multiplication is perfectly fine. That gives me $619.20. $619.20. Now, what am I going to do with that information? That is my total cost. What am I doing with that information? I'm now dividing that by 3. Excellent, Joseph. I was afraid that someone was going to divide that by 2 because it says they're on a road trip with 2 friends. But Sam counts. It's not just 2 friends. So instead of dividing by 2, I need to divide by 3 because it's Sam and 2 of her friends. So now I'm going to divide that by 3, and that's going to give me $206.40. This is a classic word problem that's just a multi-step word problem. It's not complex in what it's asking us. It's complex in the sense that we are doing lots of different steps to get to the right answer. Why am I multiplying and dividing for this problem? Because we are trying to find the total number of gallons of gas and the total amount of money, and then dividing it among multiple people. And so because of that, we're using multiplication and division to help us with that. All right, let's go back into some geometry, and we're really going to explore some geometry terminology here. So I've got 4 problems that are all very similar, but they are asking different things. So let's go ahead and get started with this exploration. How many rectangular faces does a rectangular prism have? So let's do a quick review of the difference between a prism and a pyramid. So a prism has 2 identical bases and rectangles that connect those bases. A pyramid has one base and triangles that extend up from that base that hit a vertex. So a rectangular prism is going to look something like this with two rectangular bases and then rectangles connecting those bases. A rectangular pyramid is going to look something like this, where I have a rectangle base and then I have triangles coming up to a vertex. So how many rectangular faces does a rectangular prism have? A rectangular prism is going to have two rectangular bases because it's a rectangular prism. And then it's going to have four rectangles connecting those two bases because there's going to be a rectangle for every side of my base. So there's a rectangle for this side here. There's a rectangle for this side here and the bottom and the side. So the answer to this is 6. Now, what if it said, how many rectangular faces does a pentagonal prism have? If it was how many rectangle faces, the answer would be 5. Because if it's a pentagon base, I have 2 pentagons on the side, but then I'm going to have the number of rectangles that are connecting that pentagon is going to equal the number of sides of the base. The base is a pentagon. It has 5 sides. I have 5 rectangles. If it asked how many faces does that pentagonal prism have, the answer would be 7 because I have 2 bases plus the 5 rectangles. Does that make sense? So anytime we are talking about prisms and pyramids, the name of that prism or pyramid is going to clue you in onto what kind of base we are dealing with. Now, let's look at another problem or another question about rectangular prisms. How many edges does that rectangular prism have? So let's draw it again. How many edges does that have? Well, if we're looking at the number of edges, I know that I'm going to have 4 edges for each of my bases. So edge, 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 edge. And all I've done is drawn my 2 bases at this point. And I know that my bases are rectangles because it's a rectangular prism. Now I have to connect those 2 bases. So I've already drawn 4 down here and 4 up here. Now I have to connect them. And I'm going to connect them at the corners. How many corners does a rectangle have? 4. So there's going to be 4 connection points. 4, 8, 12. See. Now, what if it was our pentagonal prism? If it was the pentagonal prism that we were talking about earlier, I'd have a pentagon here, a pentagon here. So I already have 5 and 5. Now what am I going to have to do? I'm going to have to connect those pentagons at all the corners. How many corners does a pentagon have? 5. So if I'm talking about edges, that's how I can process how many edges a prism has. Excellent job. Now, we're going to do the same processing with a pyramid. These vocabulary words are so important for everybody to know. K through 6 needs to know how to really dissect and understand 3D shapes. GK people and middle school people, these are the kinds of questions they will ask you. And 6 through 12 people, they may not ask you these kinds of questions. However, they will ask you to compose and decompose these shapes. They will ask you the surface area, the volume of these shapes, and they might ask you about them in a like a three-dimensional grid system. So it's important for everyone to understand this. You are good. I saw 16 and I was wondering where you got the 4 extra side edges, but visualizing this is really, really difficult. So I'm not surprised. It's not a big deal. Like, I have a really hard time visualizing it, so I always have to draw it out. All right, let's talk about a hexagonal pyramid. So going back to our conversation for the last 2 slides, we know this is a hexagon base. So I'm going to draw my hexagon, 1, 2, 3, 4, 5, 6. And it's a pyramid. So I know that I have triangles extending from each of these sides. Creating a pyramid. How many triangular faces does this pyramid have? They're not asking how many faces it has. They're asking how many triangular faces it has. So that said, we need to consider what they're asking. So we have a hexagon base, and then all we have are triangles extending up. So if I were to draw this as a net is a flat 3D shape, and I'm not going to have enough space over there, so we're going to move this guy over here. 1, 2, 3, 4, 5, 6. If I were to draw this as a net, this is what it would look like. Because then all of those triangles are going to pull up into that pyramid and meet at the top. How many triangles are there? 1, 2, 3, 4, 5, 6. Enough for each of the sides of my hexagon. So there's 6 triangular faces. There are 7 total faces in a hexagonal pyramid, because that hexagon on the bottom is going to count. So if they're asking how many triangle faces, it's just going to equal the number of sides of the base. If they're asking for how many total faces, it's going to be the base plus 1. All right, let's look at another question surrounding hexagonal pyramids. How many vertices does a hexagonal pyramid have? So if we think about a pyramid, let's go back to our rectangular pyramid. How many vertices does it have? Well, it has the number of vertices on my base. How many extras does it have? Just 1. So here again, the vertices and the faces are going to be equal for a pyramid. The number of vertices and the number of faces are going to be equal. So in a hexagonal pyramid, I'm going to have 6 vertices plus the 1 on top, which is going to equal 7. Excellent job. All right. We have time for one more big one. So let's go ahead. Well, we might actually have time for both of these. Let's see. This is a 6 through 12 problem. However, triangles, everybody needs to understand. So this is a right triangle. How do I know? Because they've identified the right angle here. So in the right triangle below, 0 is less than B is less than A. One of the angle measures in the triangle is arctan A divided by B. What is sine of arctan A divided by B? All right. So when we take a look at this problem, we need to think about what we're looking at. So they've identified A and B for us. And when we are talking about sine, cosine, and tangent, we know that sine equals opposite over hypotenuse. We know that cosine equals adjacent over hypotenuse. And we know that tangent of theta equals opposite over adjacent. Now, if I'm trying to find theta, which is my angle measurement, then I have to arctan, arc cosine, or arc sine both sides. So if I have sine of theta equals A over B, then theta, which is my angle measurement, is going to equal arc sine of A over B. So what they've told us is tangent, one of the angles is tangent, arctangent A over B. Well, tangent is opposite over adjacent. So if this is opposite over adjacent, then we have to identify the theta that we're talking about. So is this angle going to be theta, or is this angle going to be theta? Well, if we're looking at opposite is A, this angle is not going to be theta because opposite would be B. So we automatically know that this right here is going to be theta because opposite is A and adjacent is B. Well, if that's tangent, then we know that the sine of this same angle has to be what? They're asking for what is sine of this angle, because this has been identified as the measurement of theta. So if that's the measurement of theta, sine is going to be opposite over hypotenuse. Opposite is still A, so sine is going to equal opposite over, but we don't know hypotenuse. I can cross off B and D because they have a value of B on the top. And I can cross off A because hypotenuse is not going to be equal to one of the legs. So I know C is the correct answer. But how did they get the square root of A squared plus B squared? Where did that come from? That came from the Pythagorean theorem. A squared plus B squared equals C squared, where C is my hypotenuse. So if I square root both sides, C is going to equal the square root of A squared plus B squared, which is why the denominator is the square root of A squared plus B squared. That's an interesting problem. It looks so complicated, but if we really have a foundational understanding of sine, cosine, and tangent, this is really not that difficult of a problem. All right, last problem of the night. If x times y equals 1, what is the value of 2 to the x plus y squared power divided by 2 to the x minus y squared power? I'm going to go ahead and rewrite that because it's a little blurry. So 2 to the x plus y squared divided by 2 to the x minus y squared. So how are we going to solve this? Interesting problem, isn't it? So there's two different ways we can solve this. We can solve this extremely algebraically, or we can solve this conceptually. They told us that x times y is 1. So I have two options. If x times y equals 1, then x can equal 1 and y can equal 1. Oops. Or x can equal 2 and y can equal 1/2. Or x can equal 3 and y can equal 1/3. Or x can equal 4 and y can equal 1/4, right? Lots of different options because x times y has to equal 1. Well, 2 times a half is 1. 3 times a third is 1. 4 times a fourth is 1. Let's just pick one of those and plug it in. 2 to the 3 plus 1/3 squared. That's going to equal 2 to the 3 and 1/3 squared. Well, I can already tell this is going to become a very messy problem. And so it clues me in that that's probably not what x and y equal if I have some very clean answers over here. So if x and y is 1, and let's just assume that that's the case, let's go ahead and solve it with those numbers. 2 to the 1 plus 1 power squared divided by 2 to the 1 minus 1 power squared. That's going to equal 2 to the 2nd power squared divided by 2 to the 0 power squared. Well, what's anything to the 0 power? 1. So my denominator is automatically going to equal 1. What is 2 squared? 4. So I have 2 to the 4th power, which 2 times 2 is 4. 4 times 2 is 16. 16 times 2 is 32. So 2 to the 4th power, 2 times 2 is 4, times 2, no, 4 times 2 is 8, 8 times 2 is 16. I don't know why I said 4 times 2 is 16. So this is going to equal 16 divided by 1, which equals 16. Now, there's a very, very algebraic way that we can solve this as well. I'm going to go ahead and copy and paste this. Joseph, are you saying no that 2 times 2 times 2 times 2 is not 32? Because if you are, yeah, I caught my mistake. So let's go ahead and erase all of this. The other way that I can solve this is I have 2 to the x plus y squared divided by 2 to the x minus y squared. So I can solve this under the operation that I know that 2 to the a power divided by 2 to the b power equals 2 to the a minus b power. Because my bases are the same and I'm dividing, I can subtract those exponents. So this is the same thing as 2 to the x plus y squared power minus x minus y squared. Now, from here, I can do one of two things. I can FOIL those out and solve it that way, or I can look at this as the difference of perfect squares. I have a perfect square here minus a perfect square here. If I have a perfect square and a perfect square, I know that a squared minus b squared is the same thing as a plus b times a minus b when I factor that, right? So if this is the difference of perfect squares, and this is a, and this is b, then I can solve this by doing x plus y plus x minus y times x plus y minus x minus y. Following? Now, this is not how I would solve this problem because I was already able to solve it very quickly using some conceptual thinking. However, we all know not every problem is going to be able to be solved using some conceptual thinking. So here I have x plus x is 2x and y minus y is 0. So that cancels out. And then here I have x minus x because that negative distributes, and I have y plus y, which is 2y. So I have 4 times x times y, which really means that I have what? If I go back to this concept, then I have, or I go back to this concept, really, I have 2 to the 4xy power, and they told us that xy equals 1. So then I have 2 to the 4th power, which is still 16. You went with x equals 1, y equals 1, and got, yeah, I did too. But I wanted to show you this way because not every time we're going to be able to do that. And you and I both know that sometimes problems on the exams are much harder than the problems than we expect. And so I wanted to show you another way to solve it algebraically so that if you got a problem that you couldn't conceptually think like that, then you would be able to solve it. All right, we are way over time. We are way out of time. So we are going to say sayonara, goodbye. If you have any kinds of problems that you want to see me solve next week, please leave it in the comments. I'm going to quickly turn it back over to Dr. A so that he can say goodbye, and we will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.